Dear student, myself Rajendra Aaseri, I am Assistant Professor in Computer Science Department at Government Bangad PG College, Didwana. In previous lecture, we started a new concept on transaction management system. In that, we discussed various concepts like acid property, where A stand for atomicity, C for consistency, then I for isolation and D for durability. So all these concepts in very much detail already we discussed under the subject database and management system. So up to this transaction concept, what do you mean by transaction, how to implement the transaction in a perfect or effective manner, what are the various state occurred in a transaction, then what do you mean by concurrent transaction or concurrent execution. All these concepts already we discussed. In today's lecture we are starting a new topic called serializability. So as the name implies, serializability, it means suppose in our system there are two or more than two transactions are happening in parallel manner or concurrent manner, then we need to ensure the consistency of the transaction. Means before starting the transaction, the total value of all the read and write operation should be in stable state, and after the transaction has been happened, then also all the read and write operation value should be in stable state. That is called as consistency, right? Now serializability means in order to perform all the transaction in a system in a perfect manner, so that they don't interfere with each other, we need to serialize all the transaction in a manner. The serializable schedule is called as a schedule or set of the transaction operation, right? Now serializability, the basic assumption in serializability is each transaction preserve database consistency, right? Means due to any transaction there will be no inconsistency generated in that database system, right? Thus serial execution of a set of transaction preserves data consistency, right? So if we serially schedule the transactions, then it will definitely preserve the database consistency, right? Now next possibility is that can we do the transaction in a parallel or concurrent manner. So a possibly concurrent schedule is serializable if it is equivalent to a serial schedule. Different form of schedule equivalence give rise to the notion of conflict serializability and view serializability. Now two types of serializability are there, conflict and view. Now simplified view of transactions they are having. In this we ignore operations other than read and write instruction. We assume that transactions may perform arbitrary in any order, and they perform arbitrary computation on data in local buffer in between the read and write operation. Now our simplified schedule consists of only the read and write operation. Now comes the conflicting instruction. Conflicting instruction means, as the name implies, which conflict the operations of the other transaction is called as what? Conflicting instruction. Suppose I am having two transaction T1 and T2. In T1 the instruction is I1 and in T2 the instruction is I2. So if I1 instruction is interfering on conflicting the instruction of the I2 instruction which is of transaction T2, then they are called as conflicting instruction, and we need to ensure that there should be no confliction in the concurrent execution of the transactions, right? So let instruction I of I and I of j of transaction t of I and t of j respectively. I of I is an instruction related to t of I transaction, and I of j is instruction of the transaction t of j. Now they are conflict if and only if there exists some item q accessed by both I of I and I of j, and at least one of the transaction or one of the instruction wrote q. Very very important concept. Conflict transaction means suppose there are two instruction, one instruction corresponding to first transaction, another instruction is related to another transaction, and if they are operating on a same data item and at least one instruction is performing on the right operation, then there may be conflict. So there are various possibilities. First possibility, uh, I of I. Suppose first instruction of the transaction T of I is read of Q and I of J is read of Q. Means I of I and I of J don't conflict because both are read. It means according to the property there is no single operation that is right. So they are non-conflicting. So if both the operation or data item is same but operation is read in both the instruction related to different transaction, then they are not conflicting. Now second to four is very important. First instruction is operating on Q and operation name is read. Second instruction is related to second transaction and it is operating on same data item Q but the operation name is write. So they are conflicting. Why conflicting? Because first condition is operating on the same data item I of I and I of J both are operating on same data item Q and at least one operation is write of Q related to instruction J. That's why they are conflicting. Third possibility, I of I is operating on Q in write manner and I of J is operating on Q in read manner. So they are conflicting. Why conflicting? Because operating on the same data item and one operation is write operation, right? Next is I of I is write of Q and I of J is write of Q. Both are right, same data item. It means they are definitely conflict. So fourth option is the most conflicting instruction type. Now intuitively, a conflict between I of I and I of J forces a logical temporal order between them, right? If I of I and I of J are consecutive in a schedule, clear, and they do not conflict, the result would remain the same even if they had been interchanged in the schedule. Yes, very important. Now conflict serializability. When a schedule can be said as a conflict serializable, so if a schedule S can be transformed into a schedule S dash by a series of swap of non-conflicting instruction, we say that S and S dash are conflict equivalent. Suppose we are having a schedule. In that schedule, there are some conflicts. So if we apply some non-conflicts operation swap and we can convert that schedule in a equivalent schedule by various swap, then we can say both the schedule are conflict equivalent. But we need to apply non-conflicting instruction swapping. This clear? Non-conflicting instruction. This is called as what? Conflict equivalent. We say that a schedule S is conflict serializable if it is conflict equivalent to a serial schedule. Suppose there are transaction T1 and T2. In T1 there are some instruction, then T2 instruction, then T1 instruction, then T2 instruction. So this is concurrent schedule, and serial schedule may be T1 T2 or T2 T1. So we are saying that if the concurrent schedule can be converted into a conflict equivalent schedule by help of various non-conflicting instruction swapping, and that conflicts equivalent schedule is equivalent to the serial schedule, then we can say that the schedule is conflict serializable, right? Conflict serializable means if it is conflict equivalent to serial schedule. Conflict equivalent means the conflict equivalent schedule is giving the same answer or same output as the serial schedule is giving, right? Now conflict serializability. So here some schedule are given. If you see, the name is given schedule 3 and schedule 6. So what is happening? Schedule 3 can be transformed into schedule 6, a serial schedule. If you see, schedule 6 is serial schedule. Why? Because T1 completed first and then T2. So this is T1, after that T2. But if you see the schedule 3, T1 going to T2, then it is going further T1 and then it is going further T2. Clear? So in this manner it is what switching between the transaction. That's why schedule 3 is concurrent and schedule 6 is serial. Now see, our aim is to convert the schedule 3 into a conflict serializable. So how? By applying various swapping of the non-conflicting instruction. Right? See, Conflict serializability. So, example of a schedule that is not conflict serializable. Suppose T3 and T4, we cannot arrange this schedule in such a manner that it is equivalent to a serial schedule. Serial schedule may be T3 fully, then T4, or T4, then T3. If T3 is coming first, then read queue and write queue should be there. But in order to shift this write queue, both are operating on the same item, data item queue, and they are write operation. It means they are conflicting, we cannot swap. It means uh, write queue cannot go for up. It means T3 cannot be performed before the T4 in serial manner. It means this schedule cannot be converted into a equivalent serial schedule. That's why it is not a conflict serializable, right? See, we are unable to swap instruction in the above schedule to obtain either the serial schedule T3 T4 or T4 T3. That's why this schedule is not a conflict serializable schedule. Now next is view serializability. Let S and S dash be two schedule with the same set of transaction. So there are two schedule, one is S named as and second is S dash having same number of instruction. First condition. Now S and S dash are view equivalent if the following three conditions are met at the same time for each data item Q. First, if in schedule S, if in the first schedule transaction Ti is reading the initial value of Q, then in schedule S dash also transaction Ti must read the initial value of Q. So first is on the order of the transaction, that in the first schedule, if transaction number T of I or T1 or T2 particular transaction is reading the data item value Q, then the same operation should be in same order should be performed in the second schedule also. Then S and S dash might be view serializable. First condition. Second, if in schedule S, second condition, in schedule S, Ti transaction execute read of Q and that value was produced by the transaction T of J, if any present, then in schedule S dash also transaction Ti must read the value of Q that was produced by the same write Q operation of transaction Tj, right? So second is on the write operation. Third one, the transaction, if there are any transaction that perform the final write Q operation in schedule S, must also perform, same transaction should perform the final write queue operation in schedule S dash also. If all the three conditions are met at the same time, then we will say that S and S dash are view serializable. As we can say, view equivalence is also based purely on the read and write alone. Now view serializability, a schedule S is view serializable if it is view equivalent to a serial schedule. In conflict serializable also we said that if a conflict equivalent schedule is equivalent to a serial schedule can be converted to a serial schedule, then we will say it is a conflict serializable. Similarly, in view serializability also, a schedule S is view serializable if it can be view equivalent to a serial schedule, right? Now very important point, every conflict serializable schedule is also view serializable, but vice versa is not possible. Means if a schedule is view serializable, then it may or may not be conflict serializable, but if it is a conflict serializable, then definitely it is a view serializable. Now below is a schedule which is view serializable but not a conflict serializable. T3, T4, T5 and T6. This by using some all the three condition of view serializability, we can say that this schedule is equivalent to a serial schedule view by applying the view serializability concept. So it is a view serializable, but it is not a conflict serializable. Why? Because if you see between T3 and T4, if you want to convert this schedule in a serial schedule T3, T4, T6, then there should be swapping between these write operation, which is not possible because both are on same item, data item, and write operation, at least one write operation, at place of one write operation at least there are two write operations, so it is conflicting instruction. Similarly between T4 and T5, both are on same data item, and both operation is right. So it is not a conflict serializable. Now every view serializable schedule that is not conflict serializable has some blind write. Blind write means write two writes without a read. If you see, they are called as blind write because in between there is no read, in between there is no read, right? So to write without any read is called as blind write. Now other notion of serializability. So this schedule already we discussed. In from A we are subtracting 50, and then in B we are subtracting, in second transaction subtracting 10, then again in T1 transaction adding 50, and then 3. So determining such equivalence requires analysis of operation other than read and write, right? So that's all from this lecture. Thank you.